As for me, I just bought Bitcoin on Kraken. Also, make sure you check out Kraken's industry-leading staking service, where you can put your crypto to work for you and earn up to 20% in additional rewards annually. Payouts are twice a week, and it just takes a few clicks to get started. So visit kraken.com/TIP to learn more. That's kraken.com/TIP to learn more.
A few decades ago, private citizens used to be large enough. Private. What changed? The internet. Think about everything you browsed, searched for, watched, and tweeted. Now imagine all of that data co-opted, collected, and aggregated by third parties into a permanent public record. Your record. Having your private life exposed for others to see was once something only celebrities were about. But in an era when everyone is online, everyone is a public figure. To keep my data private, I go online and turn to ExpressVPN. With ExpressVPN, my connection gets rerouted to an encrypted server and my IP address is fast. I'm giving a random IP address shared with other ExpressVPN customers. That makes it more difficult for third parties to identify me and harvest my data. And the best part is how easy ExpressVPN is to use. No matter what device you're on, phone, laptop, or smart TV, all you have to do is tap one button to get protected. So if, like me, you believe that your data is your business, secure yourself with the #1 rated VPN on the market. Visit expressvpn.com/TIP and get 3 extra months for free. That's expressvpn.com/TIP. Go to expressvpn.com/TIP to learn more. Alright, back to the show.
Like reCAPTCHA, like when you're trying to log in somewhere and it's trying to check your identity, you have the correct password. Basically prove you're not a robot, right? By asking you, hey, in this photograph, identify the stop sign or identify the stop lights, and you click on the little squares and you identify what you see. And that is actually programming their AI to see these things out on the road. You're actually helping all these people signing into their accounts are helping the AI learn what those images are and how to identify them in the real world.
That's exactly right, and it demonstrates, again, a neural network. It shows you how fundamental this idea is. So, in addition to sort of the Tesla example we talked about, a neural network is just used for perception. It's a way for a self-driving car, whether it's a Tesla car, or it's a Google car, or a car from Toyota, it's a way of identifying objects on the road. So a street sign or a pedestrian. And the way you train that system is you need thousands of examples of a stop sign, right? And you need to feed that into a neural network. But you have to label the data, as you said. You have to identify a stop sign for the neural network. And that's what you're doing when you're signing up for those services. You're just saying, this is a stop sign. And once you do that, then the system can learn the task on its own, as long as it has a sufficient number of stop signs that have been labeled.
Well, it highlights perhaps one of the challenges ahead for AI and its evolution, because clean data is very important, right? Not all data is considered equal, I guess, and so clean data is very important. And I've read that 25% of machine learning's task is involved in just cleaning up the data involved. And I'm curious how much that matters to you. For example, Tesla is collecting just raw data from the streets, whereas something like Google's or Waymo is mainly doing simulated miles and not necessarily having cars out there on the road. Does either one produce an advantage in your mind?
It's a mix of that. Google has cars on the road as well. They also do simulation. Tesla's going to use simulation as well. They're not to the point where they're just relying on real-world data. It's always a mix, and the mix can vary. So it's about finding the right balance between those two things. You can do a lot in simulation. Cars can learn tasks in the same way through a neural network, through simulated scenarios. Basically, it's like a video game. Like you can create a city for a car to navigate, and you can train the car in that environment. But you're going to miss those edge cases that you might encounter in the real world. You're not going to have every situation defined in the simulation. That's why you have to do real world as well. So it's a balance of the two. Ideally, you would have a simulation that represented everything in the world, and you could feed that into a giant neural network and train it that way. That's the goal. But that is still a pipe dream, right? We're not to the point where you can simulate the universe and then have enough computing power to train your system using that simulation. We're by no means there, but that is the goal.
So Microsoft appears to have had challenges getting its AI department up and running the same way as some of these other companies. And of course, if you think about these neural networks, it's easy to understand how they apply to things like ad spend and being able to target people correctly and predict what they might buy and serve this up in the ad space. So maybe that's where it wasn't so applicable to Microsoft, but I'm curious, they've had a very long journey with AI that has only kind of recently, I think, gotten up to par with some of the other companies. They're sort of the tortoise in this race, I think. What do you think Microsoft's future looks like as it compares to some of the other players in the space?
Microsoft responds to the situation very differently than some of its rivals. It's amazing to me how these companies develop particular personalities, and because of those personalities, so to speak, they will respond to what's happening in such different ways. A neural network, largely because of Jeff Hinton and some of his students, starts to work around 2010. And the area where it starts to work first is speech recognition. So that Siri example we talked about, where you can speak a word into your phone and it can recognize it. That starts to work in a Microsoft lab outside of Seattle with Jeff Hinton and two of his students. He's traveled from the University of Toronto and has this working at Microsoft. And that type of speech recognition is pervasive now. It will become enormously important to our daily lives. But Microsoft, not only was it slow to kind of embrace that, but it didn't really have a place to put it. Let's not forget that. So what happens over the next couple of years is that Google deploys that on Android phones. Google had a platform it could use to exploit this speech recognition technology. It could get that onto a phone that was already in the hands of millions of people, and they could start to use that technology. Microsoft was behind in the smartphone race. They had already lost that race in some way. And what that meant was they didn't have a place for that speech recognition technology. But what I'll also add is that Microsoft was slow to realize that that same idea, a neural network, which was working so well in their lab with speech recognition, could also be used in all these other areas. It looked like, to many people at the moment, that it was only a speech recognition technology. They didn't realize it was also a way of recognizing objects and images, faces and images, of driving the types of robotics we talked about, whether it's self-driving cars or robots in a warehouse or manufacturing robots. And now it's starting to work with text, chatbots as they call them. You can train a neural network to carry on a conversation. There are so many other areas where this has started to work. And Microsoft wasn't alone in failing to realize that would happen. Most of the tech industry, most of the field, the AI field, didn't realize this would happen. It was such a weird idea at the time. There were only a handful of people who really believed in it over the decade. There was such skepticism that it was hard to break out of that, even as it started to work in one area, and even two areas. Tech industry was slow to respond. But the industry is now catching up, and Microsoft has caught up to this and other ideas. But, it still doesn't have some of the infrastructure that it needs to compete in some of these areas. Microsoft, for instance, is not building a self-driving car, right? They still don't have a smartphone, but they can compete in other ways.
Am I right, reflecting on the book, that Andrew Ng, I think, was at Microsoft wanting to build a self-driving car solely to develop the technology, not even to release the self-driving car, and then ultimately ends up at Baidu?
This is actually a guy named Qi Lu, is his name.
Qi Lu.
Yes, a fascinating guy. And we can get to this amazing story of how he tries to change the direction of Microsoft. He was one of the top Microsoft executives and started to realize that this idea was working. And you're right, one of the things he wanted to do was try to convince the company to build a self-driving car, not just to put that sort of car out on the market, because that's a way of learning where the industry is going technologically. It's a way of seeing the new technologies that are coming to the fore. His analogy was that Google had learned this through its search engine. There are so many technologies you need to make that work. And by the way, nowadays, that includes a neural network, but the search engine was a way not only of serving a market for Google, but learning so many of the other technologies that would become important in the years to come. So what he advocated was going all in on a self-driving car, if only for the future of the company in general. What also fascinates me about him, and this is a story that as I heard it, I couldn't believe it. What he wants to do is change Microsoft's direction, even in this more fundamental way. He realizes that Microsoft is so set in its ways that over the course of 3 decades, as it was rising into one of the most powerful companies on earth, it was sort of set in its ways. This happens to companies. They develop these personalities, as I said, and they see the world in a certain way. And as the world starts to change, it's hard for them to change course. And what he did was, together with a couple of friends of his, fellow technologists and engineers, he builds what he calls a backwards bicycle. It's a bicycle where when you turn the handlebars left, it goes right. And when you turn them right, it goes left. He resolved to learn to ride this bike, which is incredibly hard, by the way. It takes weeks or months to learn to do this and essentially forget everything you've learned when it comes to riding a bicycle. But he resolved to do this because he felt it would show the company and his fellow executives that you could change your way of thinking and that a corporation could change its way of thinking. And so he resolves to do this and eventually, get all his fellow executives on this bicycle, and this is going to be this way of moving Microsoft into the future. And I don't want to give the punchline because it's too good, but that's a key moment in the book where you see the way these giant companies operate and how difficult it can be to change to it.
Trying to teach an old dog new tricks, basically.
And you got it.
You touched on Google. I want to talk about them because from your book, you just get a sense for how much further along they are in so many ways than some of these other companies, and how much of an advantage that just the data pool they have is. Walk us through the deep learning that allowed Google to go from just punching keywords in the search bar to now being able to ask questions in the search engine, and what that kind of meant for the company.
This is the big area of progress right now, right? We talked about a neural network working with speech recognition, then with image recognition. Now it's what's called natural language understanding, the ability for a machine to understand the way we humans piece language together. And this works in the same basic way. You now have what they call universal language models, and that's essentially a giant neural network where you just feed text into it.